Hi! Welcome back to Marketing Statistics course. In this video we study the 9 steps for hypothesis testing using the 2-group t-test. Objective: to learn the 9 steps of hypothesis testing using 2 groups of people and the 2-group t-test. You will see that these steps parallel the steps used in the previous chapter that dealt with the 1-group t-test. But there are some important differences between steps that you need to understand clearly before we dive into the formulas for the 2-group t-test. Step 1. Name one group, Group 1, and the other group, Group 2. The formulas used in this chapter will use the numbers 1 and 2 to distinguish between the 2 groups. If you define which group is Group 1 and which group is Group 2, you can use these numbers in your computations without having to write out the names of the groups. For example, if you're testing teenage boys on their preference for the taste of Coke or Pepsi, you could call the groups Coke and Pepsi. But this would require you're writing out the words Coke or Pepsi whenever you wanted to refer to one of these groups. If you call the Coke group, Group 1, and the Pepsi group, Group 2, this makes it much easier to refer to the groups because it saves you writing time. As a second example, you could be comparing the test market results for Kansas City versus Indianapolis. But if you had to write out the names of those cities whenever you wanted to refer to them, it would take you more time than it would if, instead, you named one city, Group 1, and the other city, Group 2. Note also that it is completely arbitrary which group you call Group 1, and which group you call Group 2. You will achieve the same result in the same conclusion from the formulas however you decide to define these 2 groups.
Step 2. Create a table that summarizes the sample size, mean score, and standard deviation of each group. This step makes it easier for you to make sure that you are using the correct numbers in the formulas for the 2-group t-test. If you get the numbers mixed up, your entire formula work will be incorrect and you'll botch the problem terribly. For example, suppose that you tested teenage boys on their preference for the taste of Coke versus Pepsi, in which the boys were randomly assigned to taste just one of these brands and then rate its taste on a 100-point scale from 0 and a quarter poor to 100 and a quarter excellent. After the research study was completed, suppose that the Coke group had 52 boys in it. Their mean taste rating was 55 with a standard deviation of 7, while the Pepsi group had 57 boys in it and their average taste rating was 64 with a standard deviation of 13. The formulas for analyzing these data to determine if there was a significant difference in the taste rating for teenage boys for these 2 brands require you to use 6 numbers correctly in the formulas: the sample size, the mean, and the standard deviation of each of the 2 groups. All 6 of these numbers must be used correctly in the formulas if you are to analyze the data correctly. If you create a table to summarize these data, a good example of the table using both Step 1 and Step 2 would be the data presented. For example, if you decide to call Group 1 the Coke group and Group 2 the Pepsi group, the following table would place the 6 numbers from your research study into the proper cells of the table as you can now use the formulas for the 2-group t-test with more confidence that the 6 numbers will be placed in the proper place in the formulas. Note that you could just as easily call Group 1 the Pepsi group and Group 2 the Coke group. It makes no difference how you decide to name the two groups. This decision is up to you.
Step 3. State the null hypothesis and the research hypothesis for the two-group t-test. If you have completed step 1 above, this step is very easy because the null hypothesis and the research hypothesis will always be stated in the same way for the two group T test. The null hypothesis states that the population means of the two groups are equal, while the research hypothesis states that the population means of the two groups are not equal. In notation format, this becomes. You can now see that this notation is much simpler than having to write out the names of the two groups in all of your formulas. Step 4. Select the appropriate statistical test. Since this chapter deals with the situation in which you have two groups of people but only one measurement on each person in each group, we will use the two group T test throughout this chapter. The one group T test. A. If the absolute value of T is less than the critical value of T, accept the null hypothesis. B. Step 5. Decide on a decision rule for the two-group t-test. The decision rule is exactly what it was in the previous chapter, when we dealt with the one-group t-test. A. If the absolute value of T is less than the critical value of T, accept the null hypothesis. B. If the absolute value of T is greater than the critical value of T, reject the null hypothesis and accept the research hypothesis. Since you learned how to find the absolute value of T in the previous chapter, be set 4, 1, 3, 1, you can use that knowledge in this chapter.
Step 6. Calculate the formula for the two-group t-test. Since we are using two different formulas in this chapter for the two group T test depending on the sample size of the people in the two groups, we will explain how to use those formulas later in this chapter.
Step 7. Find the critical value of T in the T-table in appendix. In the previous chapter where we were dealing with the one group T test, you found the critical value of T in the T-table in appendix E by finding the sample size of one group of people in the first column of the table, and then reading the critical value of T across from it on the right in the critical T column in the table. See set 4, 1, 5. This process was fairly simple once you have had some practice in doing this step. However, for the two group T test, the procedure for finding the critical value of T is more complicated because you have two different groups of people in your study, and they often have different sample sizes in each group. To use Appendix E correctly in this chapter, you need to learn how to find the degrees of freedom for your study. We will discuss that process now. Finding the degrees of freedom, DF, for the two-group t-test. The mathematical explanation of the concept of the degrees of freedom is beyond the scope of this book. But you can find out more about this concept by reading any good statistics book. E. G. Keller, 2009. For our purposes, you can easily understand how to find the degrees of freedom and to use it to find the critical value of T in Appendix E. The formula for the degrees of freedom, DF, is, in other words, you add the sample size for group 1 to the sample size for group 2 and then subtract 2 from this total to get the number of degrees of freedom to use in Appendix E. Take a look at Appendix E. Instead of using the first column as we did in the one group T test that is based on the sample size n of one group of people. We need to use the second column of this table, DF, to find the critical value of T for the two-group T test.
Step 8. State the result of your statistical test. The result follows the exact same result format that you found for the one-group T test in the previous chapter. Either, since the absolute value of T that you found in the T test formula is less than the critical value of T in Appendix E, you accept the null hypothesis. Or, since the absolute value of T that you found in the T test formula is greater than the critical value of T in Appendix E, you reject the null hypothesis and accept the research hypothesis. Hi. Step 9. State the conclusion of your statistical test in plain English. Writing the conclusion for the two group T test is more difficult than writing the conclusion for the one group T test because you have to decide what the difference was between the two groups. When you accept the null hypothesis, the conclusion is simple to write. There is no difference between the two groups in the variable that was measured. Quote, but when you reject the null hypothesis and accept the research hypothesis, you need to be careful about writing the conclusion so that it is both accurate and concise. Let's give you some practice in writing the conclusion of a two-group T test. Writing the conclusion of the two-group T test when you accept the null hypothesis objective. To write their conclusion of the two-group T test when you have accepted the null hypothesis. Suppose that you have been hired as a statistical consultant by Marriott Hotel in St. Louis to analyze the data from a guest satisfaction survey that they give to all customers to determine the degree of satisfaction of these customers for various activities at the hotel. The survey contains a number of items, but suppose item number 7 is the one in. Suppose further that you have decided to analyze the data from last week's customers comparing men and women using the two-group T test. Important note: you would need to use this test for each of the survey items separately. Suppose that the hypothetical data for item number 7 from last week at the St. Louis Marriott Hotel were based on a sample size of 124 men who had a mean score on this item of 6.58 and a standard deviation on this item of 2.44. Suppose that you also had data from 86 women from last week who had a mean score of 6.45 with a standard deviation of 1.86. We will explain later in this chapter how to produce the results of the two Group T test using its formulas. But for now, let's cut to the chase and tell you that those formulas would produce the following in
a conclusion of the two-group T test when you reject the null hypothesis and accept the research hypothesis. Objective: to write the conclusion of the two-group T test when you have rejected the null hypothesis and accepted the research hypothesis. Let's continue with this same example of the Marriott Hotel, but with the result that we reject the null hypothesis and accept the research hypothesis. Let's assume that this time you have data on 85 males from last week and their mean score on this question was 7.26 with a standard deviation of 2.35. Let's further Suppose that you also have data on 48 females from last week and their mean score on this question was 4.37 with a standard deviation of 3.26. Without going into the details of the formulas for the two-group t-test, these data would produce the following result and conclusion based on. Now, you need to compare the ratings of the men and women to find out which group had the more positive rating of the friendliness of the front desk clerk using the following rule. To summarize the conclusion of the two Group T test, just compare the means of the two groups. And be sure to use the word significantly in your conclusion if you rejected the null hypothesis and accepted the research hypothesis. A good way to prepare to write the conclusion of the two Group T test when you are using a rating scale is to place the mean scores of the two groups on a drawing of the scale so that you can visualize the difference of the mean scores. For example, for our Marriott Hotel example above, you would draw this picture of the scale in. This drawing tells you visually that males had a higher positive rating than females on this item, 7.26 versus 4.37. And, since you rejected the null hypothesis and accepted the research hypothesis, you know that you have found a significant difference between the two mean scores. So, our conclusion needs to contain the following keywords.